Good morning, everyone. I am Priyanku from Electronics Department of Don Bosco School of Technology. Today, we're going to discuss the basics of VLSI designs. Uh, these are the topics we're gonna cover in my speech. We're gonna see the introduction and motivation and some of the motivations, the VLSI design process, details of the MOS transistor, and the device fabrication, some of the design rules, and CMOS circuits. Let us see. This is the first computer, the Babbage Defense Engine, which was invented in the year 1832. It has around 25,000 parts and it cost around 17,000 euros. The first electronic computer, which was invented in the year 1946, is known as it's called ENIAC, and as you can see in the picture, it uses a whole room to install just a single computer. This is the evolution in complexity graph, and it is the logic IC gates per chip versus the year. As you can see, the as the year increases, the logic IC gates per chip increases. Now let us see what is CMOS in VLSI. Now let's see what is a MOS first. MOS is called metal oxide semiconductor. This is used to mean the metal gate over oxide insulation. Now we use polycrystalline silicon, which is deposited on the surface of the ray chip as a gate. We could call this poly or just ray stuff to distinguish it from the body of the chip, the substrate, which is a single crystal of silicon. We do use metal aluminum for interconnection wires on the surface of the chip. CMOS. CMOS is also known as complementary MOSFET, and in this CMOS we are using both N channel and P channel type enhancement mode field effect transistors. Field effect means no current from the controlling electrode into the output. There are two transistors, FETs and BJT. FET is a voltage control device and BJT is a current control device. N and P channel doping of the substrate for increased carriers, electrons or holes. Let us see N channel enhancement mode MOSFET. This is a basically four terminal device which is including the substrate bias. Else, if you do not use the substrate, it will become three terminal device. Um, in enhancement type MOSFET, there isn't any channel formation at the beginning, so there is no current flow through source and the drain. So as we increase the gate voltage VGS, that is VGS, slowly the channel starts to form, and there increases the current starts to flow from the source and the drain. This voltage is called the threshold voltage. What is VLSI? VLSI means very large scale integration. Before VLSI, we had LSI, which is called large scale integration. Before that, we have MSI, and before that, we have small scale integration. Now, what is IC? IC means multiple devices on just one substrate. Now, let us see how large is VLSI. As you can see, SSI has 10 to 100 transistors in a single chip, and MSI it has around 100 to 1000 transistors in a single IC. In LSI, it is around 1000 to 10,000 transistors in a single IC. In VLSI, it has more than 10,000 transistors. We have the next generation also, which we are using ultra large scale integration. This is the Intel 4004 microprocessor. Let us see the evolution in transistor count. As you can see, as the year increases, the number of transistors it becomes almost equal to double. So this is given. Actually, this is Even actually to the Moore's law that it says that mm, every 2 years the number of transistors present in an IC doubles. Scale example: consider a chip of 220 mm into 20 mm, maybe the size, or it may be the size of 2 micrometer into 2 micrometer with area for wires, etc. It could be 1 into 10 to the power 8 transistor per chip, like that. This is the Intel Pentium 2 microprocessor VLSI design. But the real issue is that VLSI is about designing system on chips. The designs are complex and we need to use structured design techniques and sophisticated design tools to manage the complexity of the design. We also accept the fact that any technology we learn the details of will be out of date soon. We're trying to develop and use techniques that will transcend the technology but still respect it. The process of VLSI design consists of many different representation, abstraction of the system chip that is being designed. These are some of the designs which are system level designs, architecture, algorithm level design, digital system level design, logical level design, electrical level design, layout level design, semiconductor level design, possibly more. This abstraction view is itself a design hierarchy of refinements which compose the design. New design methodologies which are based on system level abstraction versus device characteristics abstraction. Logic cycle and circuit change slowly over time. Trade-offs do change, but the choices do not. Scalable designs, which are layout techniques, also change slowly, but the minimum feature size steadily decreases with time. Design approaches maybe custom, semi-custom, gate array, or EPLA, EPLD, or FPGA. Custom, it is full control of design. Best we get the best results, the slowest design time. In semiconductor, we use cell libraries over from vendor, CAD tools, and we have faster design times. Gate array, it is the fastest design time, the worst speed, power, and density, but it is the best low volume. EPLA, EPLD, which is a electrically programmable in the field. Now let us see the technology that we use. It is bipolar BJT with a TTL, Schottky, ECL, and I square. We have dual junction current control devices which are MOSFET, MOS, PMOS, or CMOS. With single junction voltage control device, you know. In the end, we can see VLSI is a process of creating an IC by combining thousands of transistors into a single chip. The microprocessor is a VLSI device. Before the introduction of VLSI technology, most ICs had a different limited functions they could perform. Thank you.